Okay, so we've seen all the different phases of case study research, and now we come to the usual chapter that we had in all our lectures. That is the threats to validity chapter. We've seen that we have to include a validity procedure in which we list all the triangulation approaches that we followed, but at the end of the study we need also to evaluate residual threats, confirm that the triangulation was effective, and list the mitigation strategies adopted for addressing specific threats that emerged during the study. So threats to validity for case study research are very similar to, in terms of names and structure, to the different threats that were discussed for experiments, because we are speaking about external validity, internal validity, and construct validity. And we speak also about reliability that is related to the possibility of replicating the same study and obtaining the same results, basically. Let's see each single. As you can see from the diagram, external validity is related to the context that are chosen. So in external validity, I will discuss to which extent my context can be seen as representative of other contexts. So in external validity, I will also discuss the fundamental features that can be used to compare my context with other companies, basically. The internal validity is related with the data collection with the data collection activity, because internal validity is analogous to the one in experiment, which are the variables that I didn't control, I could not control, and may have influenced my outcome. Okay. And construct validity is related to the analysis of data mostly, because I am dealing with mapping constructs defined in relation to research questions into actual measures. So I have to show that my analysis and the chain of relationship between the constructs and the measure that I took is sound. And the reliability, it's related to both collect data and analyze data, because reproduction of the study means reproduction of all the activity of data collection and data analysis. So threats to validity. We said that we are mostly referring to the framework of threats to validity for quantitative research, so for a controlled experiment, but actually we have to consider all the type of threats to validity that we have listed also for qualitative research, that have a different naming, but can be easily mapped to this framework, because generalizability is external validity, basically. Validity in general is internal validity for case studies. So the mapping is pretty straightforward if you have understood the principles behind construct internal external validity. Okay, so construct validity is related, as I already mentioned, to the extent to which extent I operationalize my constructs in a correct way. So how sound is the link between constructs and measures? Are there subjective measures involved? If there are, I should have applied triangulation, and I should confirm that this triangulation was used to mitigate construct validity. Internal validity related to uncontrolled variable that might have influenced the outcome of my study. So not just the variables that I could not control and are part of my context, but other aspects that may have had an influence on my study. And you can refer to the lecture on controlled experiment to have a large list of internal validity issues, and also to the lecture on qualitative studies for validity, as they were called, issues. So all those threats apply also to our cases. External validity, which are the features that makes my study applicable to other contexts, so my conclusions applicable to other companies. Reliability is related to how much evidence did I provide and how much data did I share. So in this case, evidence is related to what we discussed in qualitative study, because we want to show that there is, we are dealing also with qualitative data, and we want to show that there is a clear link between the data and the conclusion, the constructs and the data that I measured, and the measures and the conclusion that the analysis that I made and the conclusion that I provided, the results that I provided in relation to research questions. So this link needs to be evident. And in addition, since I'm dealing also with quantitative analysis, I may have done some mistake in the analysis. Okay, so I need to share also this data, for example, the requirements, and to discuss, to argue on to which extent these things can be replicated. Okay, so when analyzing threats to validity in case studies, these threats to validity in case studies may be quite extensive, because you may refer, you may need to refer to the different paradigms of research, since you are using a mixed method. You are using both quantitative and qualitative studies. So threats to validity may be qualitative and quantitative. Here are the examples of a threats to validity section, in which of a possible paper that summarize your case study. You list the potential threats to validity, and you adopt here the mitigation strategies that you adopted. For example, for construct validity, you can say that usability and accuracy were constructs, but you evaluated them in a standard way. So with the standard evaluation measures that are well accepted. So this link between the constructs and the measures is somewhat established by the literature. Okay, so you are guaranteed. Here you see that I'm not just listing the possible threats, but also how the threats can be excluded or mitigated. Of course, there was subjectivity in the data analysis, but we remember that we performed triangulation. So you see that the threats to validity, although they come afterwards, they are strictly connected to the design of the study. So that's why you should already plan for a validity procedure beforehand. Internal validity in our example is that the subjects involved can be discussed as the subjects involved in usability analysis are representative of the company analysts and have different degrees of experience, and their experience do not influence the outcome, because I've selected people with different experiences and with different background. Or I can admit that there is a threat due to the selection, and different outcome may occur if I select different people. And this needs to be admitted in the internal validity section. If your results are correct, but at the same time you have some problems with the selection of samples, this is a selection of subjects or objects, this is accepted in a case study, but you have to make it evident. And of course, for example, in focus group, I may have had another problem that not everyone may be able to contribute sufficiently. And in this case, the mitigation may be simply that that you allow them to write down their opinion beforehand and to speak it, to read it out loud before the focus group, or at the beginning of the focus group. This can be mitigation strategy. So you understand that you need to be creative. You need to consider in a systematic way the threats to validity and the strategy to mitigate them. This is one of the core characteristics of case study, and that make it different, radically different from experience report. the fact that they are systematic and you study threats in a systematic way. For the external validity, we can say that our results are applicable for large safety-critical companies with mostly local development and low-level requirements analyzed from the perspective of requirements analysts. So you see, in this case, I hypothesize that I'm using just low-level requirements, not high-level requirements like in one of our variant design. And the perspective is the one of the requirements analyst, because I imagine that I didn't involve the developer, okay? But this is already indicating you to which extent your results are applicable. You see that that is really relevant to characterize the context and what are the aspects that make your study comparable to other studies. Reliability. Since you are in a company, it is very likely that you have to admit that you cannot share the data. Okay, it's very, very common that you cannot share the requirements of the company. But it is important that you share the tool to enable replication. Otherwise, you have to explain why you cannot share the tool. And you have to show and to provide evidence somewhat that the tool was tested for correctness with respect to its requirements, so that you perform some unit test. Otherwise, your results are simply not representative of the theory that the tool was implementing, so the defect detection theory that was supposed to implement. And in some cases, in some companies, especially the safety critical one, we speak about qualified tool. If you have developed the tool according to a certain development process that is required by the norms of, for example, of the avionics sector or the railway sector, we speak about tool qualification. This may be required by your company, and if you follow that in the development of your tool, you can provide evidence that your results are even more reliable. If you cannot show that, it is acceptable, but of course the evidence that you provide is less representative, is less relevant, is less strong in terms of support to your theory. Reporting case studies. As we suggested, we must be creative, because case study is complex and iterative. The thing that you should remember is to provide a thick report of your context. So anything that characterizes your study, the peculiarity of the company, the process, the culture, everything that you can report need to be reported, because also for you that you are in the company and you're interacting with them, you give many things for granted, but the reader doesn't know anything. Okay, so the more they know, the more they can relate to what you write, and the more can understand also the relevance of what you're providing, and the applicability, of course, as for their case. And two other things that you should remember, and then I will list the sections for reporting case studies, are sections for implications for research and implications for practice. You have to ask yourself, in which way does your work advance the theory, and what other researcher can do now after what you've done? Okay, so you understand that you've gone to a company, you somehow helped the company in 90% of the cases. You do some support work for the company. So you provided your help to a specific case in a specific industry. What other researcher can do, since you are publishing in a research venue, so the other have to learn something? Of course, in our case, you can say that other researchers can improve the tool for inaccuracies, or can test in other domain and with different requirements, because you are sharing the tool and you allow them to extend the scope of validity of your study. If you don't share the tool, the implications for research are much limited. So these are things that you should consider. Implications for practice. In which way does your work help the company involved in the study and other companies? So you have to outline how the work actually is seen by the company, and what impact can have in the short term and can have in the long term. And for other companies, of course, you are sharing those tools, your tools, so other companies improve their requirements review procedures, and if you share also the source code, maybe they can adapt the tool to their own cases. So making explicit all these aspects that may seem not relevant is actually very important to give to give evidence that your study is important, needed, and then actually extend the theory and allows others to extend the theory and the practice. Reporting case studies, the structure is this one. You find in the book a more detailed structure, but this is the context that you should always keep in mind. You write down an abstract that has context and motivation, problem, provided solution, the results that you have, and the contribution to theory. So contribution to existing work, what you do, for example, as implication for researchers and practice, for example. Introduction, then background and motivation, in which you list the pre-existing theories, related work, and you make evident the need for the study, the gap, the research gap that we discussed, okay, that we discussed at the beginning. Here is the space where you describe this aspect. Then, if you are using a case study that is improving in nature, like the one that we discussed, so you are trying to improve the process of the company, you have to also discuss and describe the adopted tools and methods. So if you develop the tool, you have to explain here how does it work, what does it do, and how was it developed, etc. So this is optional that is typical for improving case studies, in which you are providing a method or a tool and you are applying to improve the process, okay? Or the tool is the output of the overall process, but still this is the area where you should place the description of the tool. Then study design. If you have a very complex case study or an iterative case study, it is useful to add an overview where you describe the structure. We will see an example in the next slides. Then context and unit of analysis, research question and constructs, data collection, data analysis, and validity procedures. What we discussed up to now, okay? In the same way that I presented that to you, of course, with words. Execution and results in relation to the research questions, threats to validity, like we discussed up to now, and discussion in relation to results and theory. So you consider your results, you discuss them, but you also link them to the theory that was at the beginning, and you explain how your work actually extends the theory. Now you remember from our diagram that we had the theory before and after the study. And then implication for researcher practice and conclusion and future works. This is a general scheme. There are two optional things, as you can see. Of course, there are variants, but your study should include these things. You can, for example, not consider in some cases the validity procedures and put everything in the threats to validity, but the other sections should be there. Unexpected results and iteration. In some cases, and I would say in most of the cases, things don't go as expected, and you may need to do different iterations, okay? Iterations may be little adjustments so that you can present in a paper also. If there was an iteration, you can present it as a linear case study, so not need to separate iteration. Or if they are relevant iterations, so change of directions, you need to make sure that you separate clearly this iteration. For example, this iteration may be due actually to some unexpected result, and but in this case you need to make clear that you have reported a clear structure of each iteration, and they should be compatible in terms of structure. We'll see an example in the next slides. Iterations are important also because you may have different stages or different goals during your whole study. Imagine you stay 9 months in a company. At the beginning, you want to understand which type of errors can be detected by your tool. So you are an exploratory study and it's descriptive, so you understand what type of errors are there. Then you want to improve the tool for inaccuracy. So it is again exploratory, but you want to improve you want to improve your tool to address inaccuracy problems, and then you want to test again the tool that you improved on a larger data set, and this is a confirmatory and improving. Okay, this is just a classification, terminological classification that allows you to identify the different flavors of the stages of a case study. Of course, the structure needs to be placed in the overview, the structure of each iteration and the overall structure of the case study. This is an example of report of a structure. You can check the paper. You can check the paper there. And here was actually concerned the study with the defect detection with NLP patterns, so natural language processing patterns, so rules basically, to understand which requirements were defective. And the example that I provided is a simplified version, very simplified version of this one. But you see at first glance the complexity of the study. Here, each iteration was planned according to the structure that you see on the left. So you have dataset selection, dataset annotation, application of patterns, that is application of the tool, and then output annotation, with which means that they performed some form of review of the output, and then the cycle continues with data analysis and again new data preparation with new research questions that are derived from the previous iteration. So this is basically the cycle that is followed in each iteration. And in the table of on the right side, you see that each iteration has a main nature that can be exploratory or improving. Here we don't distinguish between exploratory, confirmatory, between the stage and the goal, but imagine that this keyword is characterizing the main objective of the study. The research questions that are addressed in each phase of the study, and the data set that were used. This to summarize each iteration, and then you identify which phases that are depicted in the structure on the left are actually applied, and in which way are applied for the different tasks for each iteration. So for each iteration, you have an indication of the subjects. Basically, here is the subject, but not relevant to you, that participated in each step of each iteration. You see that some steps in some iteration are not covered. But this is a way of presenting a very complex iterative way, in a way that each step is comparable to each other. This is very complex because you have 5 iterations, so a very large study. But even in a smaller scale, the approach is the same. So a structure, systematic structure with with preparation, data collection, and data analysis, and some objects and subjects. Subjects are here in table 6, and objects are in table 5, and a structured presentation of the different phases. If you are more interested, please refer to the paper. Finally, some remarks on industry-academia collaboration. Why these remarks? Because industry-academia collaborations are where case studies happen. As I said before, in all the cases, you deal with industrial data, with real-world data. So you need to interact with the company. So this interaction can provide benefits and challenges for researcher, to the company, and also to the general public. Let's give an overview of these benefits and challenges. First of all, why the company should do a collaboration with you? Because first of all, they can explore some research direction, although they don't have research branches in the company. So like medium-sized companies, they can use researchers to explore possible development, possible alternative path for the development process or modification to the development process by leveraging the knowledge of the researchers. Or they can have a direct benefit because in their company you can develop something that leads to a patent. Okay, this is very convenient for them because often people that are involved are PhD students or graduate students. This means that they have low cost. These people are there learning, so it's something that for them is exciting, is a new thing, and you learn how to do things in a proper way. So it has several benefits in terms of cost and in terms of potential achievement by the company. For researcher, it is important because it's one of the ways for getting fundings. So obviously, for doing research, you need money, and this money can come from company or from research projects in which company are involved. So very often for technology transfer projects that are funded by European Union or your region. Okay. But the most important benefit, I think, for researcher is that you get to touch real data, and this usually opens up new avenue for research itself. You start reasoning not just on the problem of the company and solving the problem of the company, but you start seeing a lot of additional problems that may stimulate your research interest. Okay. So this exposure, I think, is the biggest benefit for researcher, an exposure to reality that otherwise a researcher does not have, and risk to focus their research on toy problems. This is the biggest risk, and of course it's preferable not to. And to the public, there is an indirect benefit of advancing the state of the art and the state of the practice. Of course, if you report the study and if you are able to disseminate the study in a proper way. There are drawbacks, of course, because for the company, there may be consumption of employee time. So you don't know at the beginning how much time is required by your employees, for example, for the usability study or for other degree of training that might be required to by the company employee to the researcher, and from the researcher to the company employee, depending on the design of the study. So it has a cost. It has it may lead to unexpected costs. And there may be the risk of intellectual release, inappropriate release of intellectual property, and this is also a thing that that is very crucial for companies, and often they don't allow to use their name in the papers. This is okay, but often they don't allow you to publish relevant data for your paper. So this for your research. So basically, this makes it impossible for you to create one of the most relevant outcome of your work that is not just your knowledge, but is the paper that you publish. And there are different perspectives in terms of success. For a researcher, is publishing a paper in a very relevant venue. For the company, the success is that you reach you reach a product that works and you actually transform your process. Okay, so you deal with the problem until the end, and these are things that very often you cannot publish. So the goals may be very different. For a researcher, a feasibility study may be sufficient, but for a company, is not. Okay. For researcher, the cost, the main risk is that it may take a lot of time, of your time, because maybe you are stuck there developing for the company and not being able to publish what you developed. So it may take a lot of your time, and may have a limited research freedom. So you are really constrained by the need of the company. So your creativity is somehow constrained. Okay, and there is the risk, of course, that someone ends the collaboration. For example, if they end the collaboration and you have started, for example, the PhD with the company, your PhD is at risk. So it's a risky activity. It's really challenging performing case study, but is one of the best way to carry out research in software engineering. And for the whole project, of course, there are different views of the problems from the different participants, and there might be problems related to degrees of skills of the researcher in understanding the environment and the degree of competence of the people from the company in understanding the potential of the research. And there is the risk that the results are inconclusive. And that's why often you have to iterate. But it is also important that you publish also inconclusive results. So results, if everything was set up with research questions and in a proper way, even negative result or inconclusive result may be relevant for the community because they show a road that was a dead end, for example. Here is a checklist that you should consider when you start a collaboration with a company. This is probably not for you today or tomorrow, but it's something that may happen to you in the future. So there are some decisions that are from the company, and some decisions that are from the researchers, and some are negotiated between the two parties. As usual, the important things are also bureaucratic. So how will you deal with intellectual properties? How will you deal with the publication of the results? These are things that you need to negotiate and discuss. Okay, and always put in place a plan to handling risk. Don't risk to find yourself in a situation in which you are running out of resources, you are running out of time, and so these are all bureaucratic aspects, planning aspects, but are extremely important for a successful case study. And the other detail, you can read them by yourself. So to conclude this lecture on case studies, let's look at the key takeaway messages in this summary. So case studies are context-dependent research approaches that are very common in software engineering, as we said. Why? Because software engineering itself is context-dependent, as we said. So every company has its own context, process, people, type of software, domain, etc. So as software engineering is context-dependent, the principal research strategy, research approach is context-dependent and is case study. For a successful case study, it is needed that you have a knowledge of all the empirical approaches that are available, because every situation is different. You need to be creative, but you need an empirical mindset, as I've repeated several times. So you need to know well controlled experiment, although you don't do a controlled experiment, but the terms of controlled variable, independent variable are needed to basically to avoid the possible threats to validity of your study. Case study is a structured and planned experience with industrial data. This is the shorter way of defining a case study. So well structured and well planned using industrial data with research question, data collection procedure, data analysis, validity, results, and discussion. These are the key elements that you should always put in your report, and you should also always consider in your structured analysis. Triangulation is key, and good industrial collaboration is key. So triangulation is key to achieve objectivity and generality, sufficient generality of the data. Good industrial collaboration is key, otherwise you don't get access to the data, you don't get access to the information, your results cannot be published. So key to have good collaboration with the companies. Possible recommendations. Do your best to be rigorous. Little choices can lead to unpublishable results. What I'm referring to, you may say, okay, here we don't do triangulation, but then for the ground truth definition, but then that ground truth is completely flawed. Okay, we have just one person annotating the ground truth. The value of a publication, although you spent 9 months, is much lower than the value that it would have if you involved 2 people in just annotating the data sets. Okay, so do your best to be rigorous, add little extra effort, because this can lead you to much valuable research outcome. Expect the unexpected, so be flexible. As I said, you may need several iterations to reach your goal. So be flexible, modify your search question, adjust your study. Publish also negative results and reason on what did not work. So it is important not to claim success where there was no success. This is an important issue that also the research community have been struggling to understand, because software engineering has been for many people automation of software engineering procedure, and if your tool didn't automate and wasn't successful, then your tool was useless. As we've discussed with empirical software engineering, the perspective has changed. We are focusing on analyzing what is the reality and transforming this reality. If we are not able to transform it with the strategy that we have, it is important that we admit that. It is important that we publish that the strategy was not successful, so that we don't spend other years in studying a certain technology when it was already assessed for being not sufficiently successful. This is a waste of intellectual forces and of research effort. And last thing that is very, very important is related to open research. So share as much data and information as possible. This is not always possible in case studies, because you have proprietary data very often, proprietary software, proprietary documents, etc. But you have to share what you can share. For example, if in our example, we considered sharing our tool, the tool that we developed. This is important to do so that others can replicate the study, not entirely, but can replicate your experience in a different way in other companies. And this allows to extend the scope of validity and to enrich the theory. That is always the objective of any software engineering, empirical software engineering inquiry.